This video is on solving literal equations that involve radicals. In addition to that, we'll do a couple applications at the end just to see how to solve those. So for these first two problems we have here, we're going to solve for the given variable. And, they gave us this first equation, which is t equals 2 pi times the square root of L over 32. And we're going to try to solve this for L, which means you want to isolate L by itself on one side. Whenever you're solving it for a variable, what we're really saying is we want to get that variable by itself on one side of the problem. Now, you might want to pause this and try it on your own if you're familiar with this. We've solved literal equations before, but really follow the steps for solving for a radical equation, which means isolate the radical on one side first. So if I have t equals 2 pi times the square root of L over 32, the first thing I want to do is remove this 2 pi from the side because I want to isolate the radical on one side. So to do that, you divide each side by 2 pi. And that'll leave me with t over 2 pi is equal to the square root of L over 32. And then to solve this, right, I want to get L out of this root. I have to get inside of this root, in other words. Well, how do I get inside of a square root? Well, I have to square this side. But if I square this side, I also have to square this side. So what I'm left with here is I have t over 2 pi, the quantity squared, which really means square the t and square the 2 pi. So we'll end up with t squared over 2 pi squared. For division or multiplication, remember, you can just bring the power through. 2 squared will give me 4. Pi squared will give me pi squared. It's equal to the square root getting squared just leaves you with what's on the inside. So I'm left with L over 32. And then to solve this for L, well, this is L divided by 32, so I want to multiply by 32 to isolate L on one side. So I have L on this side, which is good. On the left side, make sure you simplify. You've got 32 over 4 here. This reduces, right? 32 divides by 4 evenly to give me an 8. So I end up with 8t squared over, that's really just a 1 in the denominator, times pi squared, which is just pi squared. So L equals 8t squared over pi squared, and you solve for it. So the idea behind this is you're still solving the same way you normally would. I mean, you want to isolate the radical first, and then solve for the variable on the inside, following our normal algebra rules. For the next one here, we've got b equals the 4th root of 2e all over m. We're trying to solve this for m. Remember what that means. It means get m by itself on one side of the problem. The first thing you want to do, though, is notice m is inside that root. So you want to get the root out of the problem so you can get to the m. So to do that, all right, you have v equals the 4th root of 2e over m. If the root is already isolated like it is here, the next thing you want to do is raise to the power of the index. I'm going to raise this to the 4th power. That'll help me remove the root. Remember, if you do it on one side, though, you have to do it to the other side. So we've got v to the 4th power, which is just v to the 4th power, equals here the 4th root to the 4th power. Those, remember, the reason we did it is so they can cancel the root out, and you're left with just the inside, which is 2e over m. Now remember your goal. Your goal is to solve for what? It's to solve for m, which means you want to isolate m by itself on one side of the problem. The common mistake people make here is they try to move the 2e. But the thing you have to recognize is m is in the denominator right now. When you solve for a variable, it has to be in the numerator. It has to be that variable really over 1. You can't solve for it in the denominator. Sometimes people try to divide this by 2e, but that would still leave a 1 in the numerator over m, and we're not trying to solve for 1 over m, we're trying to solve for m. So you want to get m out of the denominator, and to get m out of the denominator, you can do it in one of two ways. You could rewrite v to the 4th over 1 and use cross multiplication, or if you have an equation with fractions, remember how you solve that. You multiply by the LCD to both sides. In this case, the LCD is just m. So multiply by m to both sides. So on the left side, I'm left with mv, and that's to the 4th power. So mv to the 4th is equal to, here, 2e times m divided by m. The m's cancel. That's why we did it, right? So m divided by m will cancel out, and you're left with just 2e. Once you have that, remember the goal. Solve for m. We get m by itself. So this is m times v to the 4th. We want to move the v to the 4th by division. So we divide by v to the 4th. You divide by v to the 4th, and you're left with m equals 2e over v to the 4th. Noticing that you know, nothing here cancels, but if it did, you would reduce it and cancel if you could. So we isolated M on one side, so we have it. When you're doing this on my math lab on the computer, make sure the case of your variables is the same case they give you in the problem, because it will matter. It'll mark you wrong if you don't use the same uppercase or lowercase. So those are a couple of literal equation examples. You know, we've solved them before, but this time we had radicals. But you still follow the same steps. You want to isolate the radical on one side, and then solve like normal by raising each side to the power of the index. We're just going to take a look at a couple applied examples here. You may want to pause the video to write this down and then work through it. So we have solved for the missing side here. So they've given us a triangle. It's a right triangle. You know it's a right triangle with this little symbol down here indicating that's a right angle, meaning a 90-degree angle. And so we have a right triangle, and we have, you know, one side here is the square root of 10. This other side here is x, and then the side opposite the right angle has a special name, right? We call that the hypotenuse. The hypotenuse is the square root of 70. When I say opposite the right angle, I'm saying just look straight across from it. So we know a formula that relates the sides of a right triangle. And this is important because this only applies to a right triangle, but the formula that relates the sides of a right triangle is Pythagorean theorem, remember. And the Pythagorean theorem says, you know, a squared plus b squared equals c squared, where a and b are the legs of the triangle. C is the hypotenuse, right? So when I go to substitute into this formula now, I'm going to use x and the square root of 10. A and b can be used interchangeably, but c is always the hypotenuse. So let's substitute in. So a squared, I'll say a is the side x. So we'll say x squared plus b squared. So that's the other leg. So square root of 10, getting squared, right? Because you're replacing b with square root of 10, equals c squared. Well, what's c? C is the square root of 70, and remember, that's squared. Now the goal here is to solve for x. Let's simplify this a little bit. So we end up with, we have x squared plus the square root of 10 squared. Well, that's just 10, remember. If you take the square root of something, you're squaring it. Because the power and the index match, you're ending up with just the inside, right? So just 10 equals the square root of 70 squared, which is just 70. And now we're trying to solve this for x. Since we just have an x squared in the problem, I'll isolate the x squared and use the square root property. So I'll subtract 10 from each side. I end up with x squared equals 70 minus 10, which is 60, because the 10 minus 10 cancels out. And then to solve this, we're going to take the square root of each side, right? That's what you do when you have x squared by itself. There are other x's in the problem. You'd have to get everything on one side and 0 on the other. Because there aren't any other x's in the problem, we just have x squared. We can use square root property, so I'm taking the square root of each side. Now, typically, you'd write plus or minus here when you take the square root, because we get positive and negative answers. But because of the fact that we know this is the length of a side, we know that this should be a positive answer, so I'm not going to write plus or minus there. So I have x equals the square root of 60, and that's fine, but if that simplifies, you should simplify it. So we have x equals the square root of 60. 60 is not a perfect square, but it doesn't have any perfect square factors. And it does, so we're going to separate this into the highest perfect square factor it has and then non-perfect square. The highest perfect square factor of 60 is 4. 4 times what gives me 60? Well, it's 4 times 15, right? You can do 60 divided by 4 to get 15 if you're not sure. And then we simplify that. The square root of 4, simplifying the perfect piece, is 2. And then the square root of 15 stays square root of 15, so we get x equals 2 square root of 15. This is the exact answer. And I expect the exact answer unless I ask you to approximate. Approximate means, you know, you would give me the decimal approximation of the square root of 60. But if I don't say that, I want the exact answer simplified, which is something that you should know how to show and do. Don't just step from this step to this step. I need you to show your work here so I know that you know how to simplify. So we have 2 square root of 15. That's the exact answer for the length of that side. If you give me a decimal there, that's an approximation. That's not an exact answer. I only want an approximation if I ask for it. Let's take a look at just one more example below. So you may want to pause this, write it down for yourself, and then try it out. But we've got a softball diamond is square with 60 feet between the bases. How far is it directly from second base to home plate? So, if you don't know baseball or softball, the shape of the infield is a diamond, and I'm going to draw it out. So you would have, home plate is here, right? And then you go to first base, which is here. You go to second base, which is here. Third base, which is here, and then back to home. So they're telling you that this is a square, right? So it's a diamond, but it's a square, meaning all the sides are the same. Now my drawing isn't perfect, but it's a square. Something you know about a square, right, is that each, angle is a right angle. So it's a 90-degree angle there, right? It's a 90-degree angle here. It's a 90-degree angle here. It's a 90-degree angle here. So they're right angles. That's important. And they're telling you, right, just drawing this out, so it's a square with 60 feet between the bases. So this is home plate to first base. That's 60 feet is what it's telling us. From first base to second base, it's 60 feet. And so on, right? It's a square, so it's all going to be 60 feet. They're asking us to find, right, what? How far is it directly from second base to home plate? Here's second base, this is home plate. So they're really asking us to find this distance here. So I'll label that X, right? That's the distance from second base to home plate. Well, if you notice what we just did, we created this right triangle right here, right? This is a triangle. It's got, right, if I just draw over this in black here, maybe you can see it a little better. So we got this right triangle here. We got the two legs are both 60, and I'm trying to find which side. Well, this is the right angle. The side opposite is the hypotenuse. So I'm trying to find the hypotenuse of a right triangle. So we really are doing what we did in the last example using the same formula. This is a Pythagorean theorem problem. You have a right triangle. Remember the Pythagorean theorem says we have a squared plus b squared equals c squared. And remember, a and b are the legs. It doesn't matter which order. In this case, they're both 60. So it's 60 squared plus 60 squared equals c squared. Well, that's my hypotenuse, which I called x, so I'll call it x squared. And then we're going to simplify 60 squared. If you're not sure, right, you have a calculator, you can do 60 squared on there. You get 3,600. You may have known that because 6 squared is 36, and then put the 2 zeros on the end. Plus another 60 squares plus another 3,600 equals x squared. Make sure you have the squared on that x. These are like terms. You combine them. 3,600 plus 3,600, that's 7,200 equals x squared. And since we just have x squared in the problem, we can solve by the square root property. So make sure you know it's a 2. So square root property says that you're going to take the square root of each side. Typically, again, you'd write plus or minus here when you take the square root. Because there's positive and negative answers that'll work, but because this is the length, right, it's a distance, you only need the positive. You can't get a negative distance there. So we end up with the square root of x squared on the right side is just x. The square root of 7,200 is what I have on the left side, and we want to simplify that. Let's get the exact answer here, and then we'll do an approximation after. So the square root of 7,200. 7,200 is not a perfect square. I mean, if you tried it on your calculator, right, really what you do is take the square root of 7,200 and you'll see it doesn't come out perfect. That would be the decimal approximation. But if I want the exact answer, I want to look at, does this have any perfect square factors? And the answer is yes. So you want the highest perfect square factor and a non-perfect square factor. Now the highest perfect square factor for 7,200 might not be obvious to you. So you might want to think of what possible perfect square factors are there. And I'm going to go through this kind of more of an instructive approach just so you have an idea of how to look at it. So let's say you notice 7,200 had 100 as a factor, because it ends in 2 zeros. So you would say, okay, well, it's 100 times 72. Well, is 100 the highest perfect square factor? Well, looking here at 72, does 72 have any perfect square factors? Well, you might know that 72 has the highest perfect square factor of 9. So that really should be going in the first radical. So it would be 9 times 100. So really you have the square root of 900 times the square root of, well, if I took the 9 out of here, that would be, I'd be left with 8. So I got square root of 900 times the square root of 8. Now you have to ask yourself, okay, does 8 have any perfect square factors? Well, yeah, it has perfect square factor of 4. So that should really be in the perfect one in the front. So this is really the square root of 900 times 4, which will give us 3,600. And then 8 divided by that 4 will give us the square root of 2, which is what's left. Now 2 doesn't have any perfect square factors other than 1, so the way you would simplify this, really the highest perfect square factor is the square root of 3,600 times the square root of 2. Now you may have been able to get this right away, but if you couldn't, this is a way to get to the highest perfect square factor in case you didn't see it. So this gives us x equals the square root of 3,600 times the square root of 2. So that's x equals, what's the square root of 3600? Well, that's going to be, we did it earlier, it's 60. And then radical 2. This is your exact answer. And this is measured in what? It's feet, right? So we should put the units on there. So 60 radical 2 feet is the distance from home plate to second base. Now, that's good. That's the exact answer, so that's how I'd expect you to write it. But if I ask you to approximate this, let's say I ask you to approximate it to the nearest tenth. Nearest tenth means 1 decimal place. Well, the approximation, you could really just use the square root of 7200, or you could type in 60 times radical 2. They come out the same. We did it before, the square root of 7200. We got 84.8. Nearest tenth means you use that number right after that, the 8, so the 5 tells you to round it up to a 9, so this would be 84.9 feet is the approximation. Remember, the approximation will be the decimal number. The exact answer will be the one that you leave in terms of a radical, unless it's a perfect square, of course. If I was to type 60 second and then take the square root of 2, notice you get the same answer. So either if you looked at it there, use the exact answer to get the approximation, or if you use the square root of 7200 here and got the approximation, you could get it that way. But we want the exact answer unless we specifically ask for an approximation. Make sure you're reading the directions, especially on any written assignments I give you, tests, or my math lab, because it'll tell you where to approximate to. If I don't tell you to approximate, it means give me the exact answer.